Slide 1, Assignment 4, Brandon T. Spears, American Military University, Business 604, Fundamentals of Business Analysis, 3 March 2024. Slide 2, Sensitivity Analysis. By conducting a sensitivity analysis, the company can assess how changes in these variables would impact the project's NPV or IRR. For instance, they could analyze the effect of a 10% increase in the initial investment cost or a 20% decrease in the expected annual revenue. This analysis would help the company understand the project's risk profile and make more informed investment decisions. Sensitivity analysis is a technique used to determine how different values of an independent variable affect a particular dependent variable under a given set of assumptions. It helps in understanding the impact of uncertainties in the input variables on the output variable. There are both qualitative and quantitative steps involved in conducting sensitivity analysis. Conclusion of sensitivity analysis is a valuable tool in capital budgeting that allows decision makers to assess the impact of changes in key assumptions on a project's financial performance. By conducting a sensitivity analysis, companies can better understand the risks and uncertainties associated with their investment projects and make more informed decisions. Slide 3, Qualitative Steps. Identify variables. Begin by identifying the key variables that could potentially impact your project or decision. These could be factors like cost, revenues, interest rates, market demand, etc. Range of variations. Determine the range of variation for each variable. These could be based on historical data, expert opinions, or industry standards. Scenario development. Develop different scenarios based on the variation of these variables. For example, consider a best case scenario, worst case scenario, and a most likely scenario. Risk assessment. Assess the risk associated with each scenario. This involves considering the likelihood of each scenario occurring and the potential impact on your project or decision. Decision making. Use the information from the sensitivity analysis to make informed decisions. This could involve adjusting your project plan, revising your budget, or changing your strategy. Slide 4, Quantitative Steps. Define the model. Start by defining the model that represents your project or decision. This could be a financial model, a simulation model, or a mathematical model. Identify inputs. Identify the inputs to your model. These are the variables that could potentially impact your project or decision. Define the range. Define the range of variation for each input. This could be based on the historical data, expert opinions, or industry standards. Run the model. Run the model for each combination of input values within the defined range. This will give you a set of results for each scenario. Analyze the results. Analyze the results to determine the sensitivity of your model to change the inputs. This could involve calculating sensitivity, conducting regression analysis, or using other statistical techniques. Decision making. Use the information from the sensitivity analysis to make informed decisions. This could involve adjusting your project plan, revising your budget, or changing your strategy. Slide 5. Projects risk into a capital budgeting analysis. Sensitivity analysis. This involves changing one variable at a time to see how it affects the project's net present value NPV, internal rate of return IRR, or other financial metrics by varying key inputs such as sales volume, costs, or discount rates you can identify which variables have the most significant impact on the project's financial performance. Scenario analysis. This involves creating multiple scenarios based on different assumptions about future events or conditions. For example, you could create a best case scenario, worst case, and a most likely scenario. By analyzing the financial outcomes under each scenario, you can assess the project's overall risk and make more informed decisions. Probability analysis. This involves assigning probabilities to different scenarios based on the likelihood of each event occurring. For example, you could assign a 70% probability to the most likely scenario, a 20% probability to the best case scenario, and a 10% probability to the worst case scenario. By calculating the expected NPV or IRR, you can incorporate the project's risk into your analysis. Slide 6, Capital Budgeting Analysis. Slide 7, in conclusion, incorporating project risk into a capital budgeting analysis is essential for making informed investment decisions. By using techniques such as sensitivity analysis, scenario analysis, Monte Carlo simulation, real options analysis, and risk-adjusted discount rates, businesses can assess the potential risks and rewards of an investment and make decisions that maximize shareholder value.